Okay, in this video, we're looking at special notes on the special triangles. This is actually our second page of notes. So the main thing with special right triangles, if we have a 45, 45, 90, draw one, it's isosceles right. There's a basic 1, 1, square root of 2 relationship between the legs and the hypotenuse. And if you have a 30, 60, 90 triangle, the basic relationship is 1 for the shortest side opposite the 30, radical 3 times 1 for the medium-sized leg, and then the hypotenuse is going to be twice the short leg, or 2 times 1. So we have a 1, radical 3, 2. So we got 1, square root of 3, 2, and we got 1, 1, square root of 2 for the 45, 45, 90s. So let's see how this works with these others. So looking at this example here, we've got a 1, square root of 3, 2 basic ratio. And if we go down and we look at the one below it, we've got a 3 and a 6. This side here is going to be 3 square root of 3. 3 times 2 makes the 6. 3 times radical 3 makes the 3 radical 3. Here they want us to find the adjacent over the hypotenuse using reference angle A. So here's our reference angle. If you imagine that you're standing inside the triangle at the reference angle, which is A for this one, and you take out the hypotenuse, which is always the longest side, or the side opposite the right angle, hypotenuse. So if you're standing at the angle, the side you can touch is the adjacent side. The side you look across at is the opposite side. In other words, the side that makes up the angle that's your reference angle in besides the hypotenuse, that side is your adjacent side. The side that's on the other side of the triangle then is your opposite side. So they want us to find adjacent over opposite, or adjacent over hypotenuse. The adjacent side is 3. The hypotenuse is 3 square root of 2. We have to simplify by rationalizing the square root part out of the denominator, which gives us 3 square root of 2 over 3 times root 4, which is 12, which ends up giving us square root of 3 over 4 for the simplified radical form for this hypotenuse. Over here we have a 45, 45, 90. Same deal. We want to use angle A as our reference angle. The adjacent side is going to be the side we can touch. The hypotenuse is the side opposite the right angle. So adjacent over hypotenuse, we have 1 over square root of 2. We have to rationalize the denominator on that one by getting rid of the radical in the denominator. So we end up with radical 2 over radical 4, which simplifies to 2. So that is root 2 over 2 when it's simplified in simplest radical form. Let's look at 45, 45, 90 triangle. In a 45, 45, 90 triangle, both legs are congruent and the hypotenuse is equal to radical 2 times the length of a leg. So the leg times radical 2 makes the hypotenuse. Let's solve for the variables. Write your answers in simplest form. So if this is the 45, 45, 90 first off, which means it's isosceles. That means that x must also be 8, and y is going to be 8 times the square root of 2. In number 2, root 2 is one of the legs, so the other leg is also root 2, And y is going to be root 2 times root 2, which is root 4, which is 2. So we get 2 for y on that one. Just circle the answers. For number 3, we have a 45, 45, 90 again. If 60 is one of the legs, the other leg is 60, and the hypotenuse is going to be 60 times the square root of 2. Let's move on. Looking at number 3, we have the hypotenuse. It's 45, 45, 90. The hypotenuse is 15 times root 2. The short side times root 2 makes the hypotenuse length. So the x must have been 15, and because it's isosceles right, the y must also be 15. Looking at number 5, 8 is radical 2 times x. So x times radical 2 came out to be 8. X is going to be 8 divided by radical 2. Rationalize the denominator by multiplying by radical 2 over radical 2. We get 8 radical 2 over square root of 4, which is 2. That gives us 4 radical 2 for the simplest form. So x is 4 square root of 2. Looking at number 6, we've got root 5 and root 5 for the legs. It's isosceles. It's a right triangle. Must be a 45, 45, 90. And root 2 times root 5 is going to be the hypotenuse length. That's going to be square root of 10. So those focus on the 45, 45, 90s. Let's look at the 30, 60, 90s now. So the hypotenuse is twice the shortest side. Shortest leg, say. And the longer leg is root 3 times the shorter leg. So hypotenuse is twice the shorter leg. The middle length side is root 3 times the shortest leg. Let's see what we got here. Okay, we got 40. Now 40 is the hypotenuse. That's twice the shortest leg. That's going to be a 20. And 20 times root 3 then is going to be our y. Look at number 8. We've got 2 radical 3. Now this is twice the shortest leg because it's the hypotenuse. So the shortest leg is going to be divided by 2 is just going to be radical 3. And then the medium-sized leg, or the side opposite the 60, is going to be root 3 times the short side, which is root 3. Root 3 times root 3 is root 9, which is going to give us a 3. So that's what we get for those. Looking at 9, the short side is x. Double the short side came out to be 10, so x must be a 5. And 5 square root of 3 must be the side opposite the 60. So look at number 10. We've got a 12 for the side opposite the 30, which is the short side. So twice that, or 24, is going to be the hypotenuse. And 12 times the square root of 3 is going to be the side opposite the 60. Looking at number 11, the short side is y. The medium side is y times the square root of 3. So y must have been 2 because we have 2 root 3 for this one. Y must have been 2. And then double 2, or 4, is going to be the length of the hypotenuse. So look at number 12. Opposite the 60, we have 9 root 3. Now that's root 3 times the shortest side. The shortest side must have been a 9 to give us 9 root 3. And then double the short side, or 18, is going to be the other, or the hypotenuse of the triangle.